This morning's talk comes to us from Saju Salahudeen. Saju is from Nokia. The title is A New gRPC Service for Transport Layer Security Configuration. Saju is presenting this coming to us from Nokia, and you're basically out of San Jose, correct? Yeah, Toronto. Gotcha, thanks. I appreciate that. It's not on here, so that's why I asked the question. Anyway, Saju, thanks for coming on board. Appreciate it. Look forward to a great talk. Welcome, everybody.
Thank you, Steve. Good morning, all. It's good to see all of you. As a network engineer, I had my initial challenges when configuring TLS for the first time. This was like 6 to 7 years back when streaming telemetry was getting a lot of attention. So most often I would end up on the internet trying to look up a procedure for configuring certificates. I would run some weird commands which I had no idea what it was doing. X509, PEM, DES, you call it. And if it works, great. If it doesn't, most of the time it doesn't. I have to repeat the procedure, right? Over time, I got a hang of it. And if you haven't tried TLS certificates yet, don't worry about it. We have much better tools these days, and we are going to talk about some of those tools today. So in this session, we are going to talk about some of the challenges network engineers face when configuring TLS certificates. What are some of the common tools available today for configuring them? What are some of the, we're going to deep dive on 2 of those solutions, specifically on the gRPC services that are available today for configuring TLS certificates. Okay. So let's start with why do we need TLS and certificates, right? Why break our head configuring something that's unknown to a network engineer? The closest thing that a network engineer has come to a security standpoint is maybe BGP, right? You would set up BGP authentication, set up the same passwords on both sides, and that's it. We are secure, right? But don't forget to enable MD5, right? MD5 hashing. And TLS was completely different, right? So why do we need TLS? Well, the matter of fact is that there are bad actors out there trying to steal information, trying to steal your customers' information, and making a profit, right? So as of the beginning of this month, there have been 13 data breaches reported. And I'm pretty sure there are more that were not reported, right? So these data breaches are for the purpose of getting customer data, sensitive data, right? So we need to protect our network as well as the data of our customers. So that's why we need some mechanism to protect that data, right? So that's where TLS comes into the picture. And how does TLS helps? So TLS encrypts the data between the 2 parties. So let's say there's a client talking to a server. It encrypts the data so that nobody in the middle understands what they're talking about. It also authenticates the client and the server. So they know that they are talking to a valid person or a valid party and not somebody spoofing themselves as a client or a server. They also help to verify the integrity of the data so that to make sure that it is not corrupted or it is not modified by somebody in the middle between a client and a server. So these are some of the characteristics that TLS helps with the communication between a server and a client. Now let's look at an overview of TLS, right? So this is a step-by-step procedure of how TLS works. But most of the challenges are before this happens, right? To configure TLS, to set it up, and make it work, right? Once it is set up and working, then we are all good, right? So let's see how it works once it is set up. So step 1 is you have a client. Let's take an example of a client that is collecting telemetry stats, and you have a server. In our case, in the networking world, our server is our router, right? So the client connects to the router. So there's a TLS handshake happening. During the TLS handshake, the router presents a certificate, a TLS certificate to the client, okay, and the client verifies the certificate. So now the client knows that I am talking to a valid router and I can go ahead and start communicating with that router. So until step 3, this is the basic minimum or the bare minimum that you need to set up TLS, right? Optionally, you can also get the router to validate the client, right? So in this case, in step 4, the client sends a certificate back to the server, and the server will validate, okay, this is a valid client, I know this client, there's nobody spoofing themselves as a client, so I can start my communication. So once that is set up, then you have two-way TLS communication, and it's commonly called as mutual TLS or MTLS. Right? So after that is done, then you can start sending your streaming telemetry or whatever data you want to send between your client and the server. Now, let's look at what are some of the security aspects that we have on the routers today, right? So we can start with the non-TLS versions, the most common ones. So SSH is very common these days. I mean, one of the first things that we check when we deploy a new router is disable Telnet, enable SSH, right? Because SSH is more secure than Telnet. Then we have BGP authentication and other protocol level authentication that I mentioned before. There's also encryption of passwords that are locally stored. If you're using local authentication, the passwords are locally encrypted. You can also encrypt the configuration files. And then there's data plane encryption. Most of you are aware of MACsec, IPsec, which is layer 2, layer 3 encryption. And there is AnySec, which is coming from Nokia, which is a combination of layer 2 and layer 3 encryption. Now coming to the TLS side, there's SNMP v3. I mean, SNMP v3 has been there for quite a long time, but it's not widely deployed. And my belief is that it was not deployed because of the complexity of setting up SNMP v3, right? Between your SNMP collector and your router. And then gRPC services. I mean, personally, I think TLS became more prominent because of gRPC, right? Because of streaming telemetry, people wanted to get data out of the routers and they wanted to be secure. PCEP also supports TLS. Then there is LDAP and Radius for your user authentication. Syslog is another common one that's that we are seeing these days. TLS used for syslogs. And then secure ZTP. So ZTP is zero touch provisioning. So you can have TLS certificates for booting up your box using ZTP. Now, what are some of the challenges that we face when configuring TLS on the router? So earlier we saw what happens after TLS is configured. So we saw the steps when the server exchanges a certificate and the client exchanges another certificate. But before that happens, we need to set up TLS on the routers, right? The most common issue that we face is generating certificates, right? So when I was starting with TLS about 6 to 7 years back, there was no option to generate the certificates on the router. So we had to generate the certificates outside the router, get it signed, transfer it over into the router, and then set it up, right? But these days with modern operating systems, we are able to generate certificates on the router itself. And the issue with that is the initial communication is unencrypted. It's not encrypted, right? So you are transferring a certificate over most likely in plain text, or if you use SEP, that's still encrypted. So that initial communication is unencrypted. And the other challenge was, how do you validate that a certificate is good, right? Again, you have to have the certificate outside the router and validate it using some tools like OpenSSL. But again, these days, the modern operating systems, they support commands to validate the certificate within the router itself. And then once you get the certificate done, the other challenge was configuring the applications to use those certificates. So we saw the list of applications on the previous slide. Now configuring those applications to use those certificates, okay, that was another issue. And then finally debugging, right? If something goes wrong, okay, how do we debug, right? OpenSSL has a debug option, and you'll see a lot of commands or a lot of logs if you enable the debug option. That how do you figure out what's happening, right? Most often you will just see that TLS handshake failed. It doesn't mention anything else, right? Then you have to, again, recreate your certificates, re-sign them, and repeat the procedure. So this is a statement at the bottom from the gRPC service called gNOI. And this is what we need, right? The system should have a clear and direct method for installing and updating certificates. This is the goal of these gRPC services that we are going to discuss today. So let's look at some of the common tools that are used for certificate management today. Right? The most common one is OpenSSL. I mean, everybody should be familiar with this. So OpenSSL has been there for some time now. It's used for generating certificates, getting them signed. You can also generate a certificate authority certificate with OpenSSL. And then once we generate the certificates, we transfer them over to the router. You can also use the router CLIs these days to generate the certificate. This is a screenshot of the Nokia SR Linux CLI for generating certificates on the router. You can also generate a self-signed certificate on the router itself. Then there are other tools available in GitHub that makes it easier for you to generate certificates and use them. Container Lab, I hope most of you are familiar with Container Lab. Container Lab is used as a network emulation software, but it also has some cool tools to generate certificates and sign them and so that you can use them on your routers. Right? And then gNOI. So gNOI is a gRPC service that can be used for certificate management, and we are going to go into a deep dive into gNOI. gNOI, the client for gNOI, is a client that you can use to generate those certificates and use them on the or transfer them on the router. Okay. So we talked about gNOI. That's a gRPC service. So let's have a quick introduction of gRPC. Now gRPC is most commonly used synonymously with streaming telemetry, right? Whenever people talk about gRPC, they mean streaming telemetry, right? But gRPC is the framework that enables streaming telemetry. Within gRPC, there are multiple services, and one of the services is called gNMI, which is used for streaming telemetry, right? And there are other services. We are going to talk about gNOI service, which is used for operations, and also a new service called gNSI for security interface. So the advantages that gRPC brings is with the HTTP2 format. So with HTTP2, there's an efficient connection handling mechanism, and it also gives you bidirectional streaming, which you need for things like streaming telemetry and also for other operations on the router. And then with HTTP2, the payload is encoded in binary format. So it makes it easier for sending and understanding the data. Now, any gRPC service that you run, it needs a client and a server. So gRPC should be there on the client side, and then the router should understand the gRPC messages. Right? So let's look at the two services within gRPC that we can use for certificate management, for TLS management, right? The common one is gNOI. So gNOI is gRPC Network Operations Interface. It has been there for, I would say, about 3 or 4 years now. Many people use gNOI for certificate management and to manage TLS on the router. gNSI is a fairly new service part of gRPC, and gNSI is gRPC Network Security Interface that was developed maybe last year or end of 2022. And gRPC was developed specifically for security related operations on a router, right? gNOI, you could do things like software upgrades, or you could do a ping or a trace route using gNOI, but gNSI is only for security related. So it could be for TLS management, it can be used for your user authentication or user profile management. That was the purpose of developing a separate service for security. Let's look at some of the RPCs or the calls that gNOI can make to a router, right? And I want to focus specifically on the first one, the can generate CSR, right? So this RPC or this message, when a client sends to a router, if the router has the capability to generate a certificate, it will say, yes, I can generate a certificate, and it will generate a certificate. Now that capability is very important, because in the beginning I mentioned that if the router does not have the capability to generate a certificate, you have to generate the certificate outside the router, right? And that itself, there is a security risk there, right? So if the router is able to generate the certificate, then you're good. So the router will respond back saying yes, and it will respond back with a certificate request. And then you can sign the certificate and then send it back to the router. The other RPCs are pretty self-explanatory. You can install a certificate, rotate a certificate, revoke a certificate, right? All those are certificate-related RPCs, part of this cert service within gNOI. Now, what is missing in gNOI, right? We saw all those RPCs, but there are some things that are missing in gNOI, because of which gNSI was developed and these certificate services were moved to gNSI. Right? The first one is the profile management on the router. So after you configure the certificates, you need to enable those applications on your router to use those certificates. And that's commonly done using something called a TLS profile. Right? So you would go on the router, you configure your certificate and your key, and you enable a particular application, for example, gRPC. You enable gRPC to use TLS certificates. Okay. So that TLS profile management, before gNSI came in with gNOI, you had to manually go on the router, type in your CLI commands to enable that TLS profile. So that was missing in gNOI. And then certificate revocation list. So revocation list is something where the client tells the router that this particular certificate is invalid or you cannot use it anymore, right? So that is a revocation list, or in short, it's called a CRL. So in gNOI, we could revoke a single certificate, but we could not send a list of certificates that are revoked. So that was missing in gNOI. And then loading the initial certificate. So when the router boots up, there was no initial certificate that was part of the router. So our initial communication was unencrypted. So again, that was a security risk there. So that loading the initial certificate was missing from gNOI. So you had to get it separately signed from outside the router on your client side and then send it over to the router. So that brings us to gNSI. So gNSI is gRPC Network Security Interface. It was defined for getting security related information or configuring security related information on the router. It is an open config standard and it is still being developed. One of the first things that came out from gNSI was for certificates. So one of the key requirements for gNSI is to have a default TLS profile on the router. So when the router is shipped from the factory, along with the initial configuration of the router that comes from the factory, the router should have a default TLS profile. It should have a self-signed certificate so that our initial communication to the router is encrypted, right? So you remove that security risk of that initial communication with the router. So the default TLS profile is there on the router, and you can select to use either the default TLS profile or you can create a new TLS profile and use that with your own certificates. So again, the key here is that the initial communication to the node is encrypted. So let's look at some of the RPCs that are there. So gNSI can be used to install a certificate. You can use to rotate a certificate. You can use to revoke a certificate, right? Again, this is only the certificate portion of gNSI. There's other services or other RPCs within gNSI that can be used for your local user authentication. So the first three RPCs that I want to talk about here is related to the profile on the router. So we mentioned that in gNOI, there is no RPCs or APIs that you can use to configure the TLS profile on the router or configure the applications that will use those certificates. So in gNSI, we have this add profile, delete profile, and get profile RPCs that can be used to manage the TLS profile on the routers. Okay. And then there is the can generate CSR, which is the same as the gNOI one. So this will ask the router, the client will ask the router by sending this RPC, hey, can you generate a certificate signing request or certificate for me? And if the router has that capability, which it should if it supports gNSI, because one of the key requirements of gNSI is to have that default TLS profile and a default certificate, right? So the router will respond back saying, yes, I can generate, and this is a certificate that I generated. And then it can be used to rotate your certificate. So the rotate RPC is used for both installing a new certificate as well as rotating an existing certificate. And then we also discussed about gNOI was missing the certificate revocation list. So that also is supported now with gNSI, where you can send a CRL bundle or a revocation list bundle, which has a list of certificates that are no longer valid. So you can send from the client to the router with that CRL bundle through gNSI, and the router will take care of that. So this is an overview of the RPCs that are supported within gNSI for certificate management. And in summary, so again, recapping what we discussed so far, so gNOI, it can be used, and it is used today for generating certificates, installing certificates on the router, and revoking a specific certificate. And what it is missing is configuring the TLS profile on the router, which is where you define your applications that will use those TLS certificates. And then gNOI also doesn't support sending a revocation list, which is a list of certificates that are invalid. Right? And then comes gNSI. gNSI will support your profile management using your add profile, delete profile RPCs, and it will also support sending a CRL or a revocation list bundle to your client so that the client will take care of all the invalid certificates. So that's all I had for this morning. Any questions? Yeah,
Please come up to the mic, list your name, company affiliation.
Naveen Achuta from Roblox. If you're using gNOI, let's say, can you rotate the certificates without downtime if you have an active gRPC service being used?
That's a good question. I haven't tried that, to be honest, while there's an active gRPC session that runs on TLS. So the question was whether can you rotate a certificate while that active session is ongoing, right? So typically, I would say no, because the router deletes the certificate from the configuration and activates the new certificate. So your TLS session would go down normally. Yes.
Okay, so that means after the rotation, we will have to redeploy the gRPC client and then start.
Correct, reinitiate the session from the client. Yeah. There was a question there.
He's walking up. No, he's not walking up. He's just walking up. Anything remote, Liz?
Yeah.
Nope.
There's
No
one.
other questions. Got it?
Michael Bone with E+. Is there recommended tutorials that you guys have? Like I can go to Container Lab and see a whole bunch of tutorials. Is there one specifically on how to set up gNMI using like Python or something, or just in whatever way? What are some of the best tutorials you would suggest to go through to learn it?
For certificate management? Okay, unfortunately, I didn't find any, but I am working on a tutorial for gNOI, specifically how to set up gNOI for certificate management. And for gNSI, a client is in the works. Okay, that will be released soon. So once that's out, we will definitely put a tutorial out for how to use gNSI client to configure the certificates and the TLS profile.
No more questions?
Any other questions?
Saju, so you've already given them the fact you're working on the tutorial on gNOI is the next thing you're going to talk about. So last time you were with us in Charlotte, you talked about gNOI. This one now talking about TLS. Now we're going to have a tutorial from you. It's all looking good. Thanks so much. Appreciate it.
Thank you all.